Welcome to our AriserTalent, my dear students. I'm Arpita Sharma, your maths teacher. Now we are going to discuss circles. Basically, we have gone through the circles and its properties and the tangent and its properties and the theorems. And now we are discussing some questions and some theorems based on tangent and its properties, right? So, here we were discussing about for this question that we have to prove that a parallelogram circumscribing a circle is a rhombus. Okay, so I was telling you students that what a rhombus is and what a parallelogram is and what are the properties. I am telling you that if you are having a quadrilateral, A, B, C, D, A, B, C, D, A, B, C, D, such that this AB is parallel to this CD and this AD is parallel to what? This BC. So, if you are having this condition, you will call it what? Parallelogram. Okay. Now, if you are dealing with the parallelogram, you will be having AD, this AD equals to BC. The opposite sides are basically equal. Okay. And this AB equals to this CD or called DC. Okay. So, these two sides and these two sides are basically equal. Now, what is rhombus? When you talk about this rhombus, basically it is a special form of parallelogram where these two relations are true, but also this AB and DC equals to AD and BC. So, basically these four sides, if these four sides are equal, then this parallelogram will become rhombus. Okay. So, now you have clear the thing and the properties of parallelogram. This angle and this angle will be equal, this angle will be equals to this angle. So, these two angles are equal and these two angles are equal. But I am focusing on this property, that this and this side is equal and this side is equal, because why? Why? Because this properties of our use in this theorem. Now, it's for parallelogram, for rhombus, these four will be equal. Okay. Okay, students. So, let's move to the proof. Right. So, I am having this parallelogram circumscribing a circle. Okay, students. So, we are having this parallelogram. So, I am drawing the circle first. This is my circle. Okay. Now, I am having a point. Okay, students. So, this is our circle. Now, let's have this tangent here. So, if I am having this tangent here, okay. So, the parallel tangent I will be having here, because I have to make parallelogram. So, this will be parallel to each other. Okay. Now, if I will be having this point and I will make this parallelogram here. Okay. So, this is a parallelogram. Now, I am having this parallelogram A, B, C, D. Right, students? Now, in this parallelogram, it is touching the points at these, let us suppose P, Q, R and S. Now, I have to prove that, what I have to prove? In order to prove that this is a rhombus, I have to prove that CD equals to AB equals to BC equals to what? AD. These four sides are equal. So, what will I do? No construction at all. I will simply doing this by the properties, right? So, is the solution, or you can write proof. Okay. So, talking about the proof, this is our circle, right? These are our tangents. This is SB tangent. Okay. Now, if this is tangent and this is tangent, this is an external point B. External point B, from this point I am having this tangent and I am having this tangent. So, you know this, these two tangent length will be equal. So, RB will be equals to SB. Similarly, can I say PA equals to AS and DP equals to DQ and CQ equals to SI, students, right? So, in figure, what we are having is this DP equals to DQ, then this QC equals to CR, then this RB equals to SB. Now, this AS equals to AP. Okay. So, this four relations I am having, DQ and DP, then QC and CR, then RB and SB and AS and SP. Okay, AP, sorry. Now, I am having this first, second, third and fourth equation with me. Now, what will I do? I am having this AB equals to CD, right? I am having this AB equals to CD. Okay. So, if these are two equal, so can I use the property that this AB equals to CD to prove that these all sides are equal by having this relation in it? Okay. So, what will I do? I will have the summation AB plus CD. Okay, so now if I am taking AB and CD, what will I have? I will have AS plus SB plus DQ plus QC. I am having this, right? Now, AS equals to AP. Now, this AS equals to what? AP, right? And this SB equals to what? This SB is equals to BR, right? And this DQ is equals to DP and this QC equals to CR, right, students? So, if I exchange these all things, I will be having here AP plus RB plus this DQ will be replaced by DP and QC will be equals to CR. So, now when I will join them, AP plus RB, AP plus AP plus this PD is equals to what? AD, right? And this RB is here and the CR is here, is equals to CB. So, what this give me? That AB plus CD equals to AD plus CB. This AB plus CD equals to AD plus CB. Now, students, this AB is equals to DC. With the property of parallelogram, AB equals to CD. Why? Sides, or I can say more appropriately, opposite sides of parallelogram, right? So, by this I can say AB equals to CD and this AD equals to CB, AD equals to CB. So can I write this as 2AB? 2AB equals to what? 2CB. 2CB. This implies that AB equals to CB. AB equals to CB. Now CB is equals to what? AD. But CB equals to what? This CB is equals to this AD. Okay. So by this 5th and 6th equation, you can say that AB equals to CB equals to AD. So here I am writing it. AB equals to CB. Can I write CB as BC? Okay. BC equals to what? AD. Okay. Now AD, this AD equals to CB. Okay. And AB was equals to CD. So I have proved that. Now this is a parallelogram with all sides equal, and if a parallelogram having all sides equal, then it is what? A rhombus. Okay. Now because parallelogram having all sides equal, it's what? So it is this ABCD is rhombus. Right, students? Hence proved. So what we did? We just did the additions of these two and replaced this particular segment by this segment by this segment. By what? By this property that if you are having a point outside that circle, then the tangent from this particular outside point will be equal. Okay. So note this so that I am gonna rub this. Okay. Okay, students. So next is this. You are having this, find the length of tangent drawn of a point. Now a tangent is drawn from a point. So here is something, a circle. Okay. Now a tangent drawn outside or inside, whose distance from the center of circle is 25. So obviously it is not on the circle. So if it is not on the circle, it cannot be inside the circle. So it will be what? Outside the circle only. So it is saying we are having a tangent drawn from a point whose distance from the center of the circle. This is our point P and we have drawn a tangent to this. Okay. Now let's make it more clear. Okay. So, right. Now this is T, tangent. Now distance from the center of circle, this distance is given what? This distance is given 25 centimeters, and given that the radius of the circle, now radius, if I meet this T with this center O, will it give me the radius 7? Now this is the right angle now, this is right angle. Okay, so I am having a triangle here which is right angle. I am provided with one angle, one side and second side, and I am asking for the remaining side. So I can easily tell that. So it's a very simple question, students. So we will not have that much time for that. Okay, so we will just calculate like in triangle OPT. PT is perpendicular PT. This PT is perpendicular to this OT. PT is perpendicular to OT because TP is tangent and OT is radius, right students? Okay, now this implies that angle, or I can directly apply the Pythagoras theorem here. By Pythagoras theorem, I can have this PT square plus 7 square equals to what? This 25 square. Now it will be PT square equals to, that will be minus of 49 and that will be 625. Okay. So PT square will be equals to what? 6 here, 7 here and 5 here. Now this is square of what? The square of 16 no 26 26, right. So it's a square of 26. Okay, so I can write it like this. So PT is equals to what? 26 centimeter. So this is your answer. Okay students. So have this question. Now students, I am rubbing this and we are discussing, we'll discussing the next question now. Okay. So what is the next question? Your next question is P and PB are tangents from P to the circle. Okay. So P and PB are tangents. So this is circle and P and PB are two tangents. If two tangents are P and PB, the common point is P. Okay. So it's outside the circle, this P, and we are having this PA and this PB. Okay. With a center O. So this is O. At point M, a tangent is drawn cutting PA. So PA, cutting PA, a tangent is drawn at point M. So this will be, okay, or you can make it more circular so that this will be easy to understand. Okay, at this point, particular point M, I am having a tangent. This tangent I am having. And again what? Cutting PA at K. PA at K, it's K, and PB at N. So PB at N, right? Now prove that. To prove we have Kn equals to, now what is Kn? This K and this N is equals to AK plus Bn. Now what is AK? AK is this and Bn is this. So you have to prove this. So for this, you should have some construction over there. Now basically you need to prove. Now I will show the construction by white chalk. So this is your construction 1. Okay. Now this is second and this is third. Right. And now this is fourth. Now in order to prove that this Kn is equals to what? AK. AK is this plus Bn. Bn is this. Okay. So I have to tell you that this particular length is equals to this length and this length, right? And you can say that there is some symmetry in this. So we can use that symmetry also. Okay, students. So note this diagram. Okay, students, drawn it. So now what will be having? So you will write this construction part, right? You will write this construction part that meet O to A and O to B and also P to O. Okay students, now you will be having, see this is an external point, this is an external point. This external point is going here and here. This external point tangent is going here and here, right? Here and here. So, if this is an external point and the tangent is there, so what will you say? That this Ka will be equals to this Km and this Nb equals to this Nm, right students? You will say like this only. Okay. So, in my proof, I am using the same thing. What I am using, that in figure, this PA equals to this what? PB, right? Why? Tangents from a common point. Okay. Similarly, I can say that this K equals to Km and this Mn is equals to what? Nb. This is third. Okay. Why? In this K and here this point K and N, okay, K and N are corresponding points for tangents, okay. So, that will be equal, these two tangents K and Km will equal, like this, if you are having this point here and then this Nm and Nb will be equal, okay. Adding second and third. Now, what you are doing? You are adding second and third. What will you have? This K plus Mn equals to Km plus Nb, okay. This K plus Nm, this Ka plus Mn, okay. So, can I do this thing? I have to write this Km plus Mn, okay. So, I am having this and this side in addition and this side is addition, okay. So, can I write this as Ka plus this Ka, so it's not K, yes, Ka plus Nb, this and B, I'm wanting Mn, so Ka plus Mn, right, equals to Km plus Nb. Now, this Ka plus Mn, this Ka, just rewrite it so that we will not be confused at it. This Ka is here equals to Km, right, and this is equals to this. Now, I have to add and I have to got the Km plus Nm. So, from here I am taking this term Mn plus here I will be having this Km. So, I am using this term plus Km. So, in this part I will be writing this Nb or Bn plus Ka, right. Now, this Nm plus Km, this Nm plus Km is what? Kn. So, Kn is equals to what? This Ka plus this Nb, okay. So, by this equation I proved that this Kn equals to K or Ak plus Nb or Bn, okay. So, it's proven here. How we proved it, what the process we have applied. We treated this as an external point and the two tangents are equal. We just applied this formula. So, note this students so that I can rub it, okay. Okay students, going with the next question. Right, in this question you are having a figure and O is the center of the circle. O is the center of the circle. PA and PB are tangent segments. PA and PB are what? Tangent segments. Show that the quadrilateral AOPB is cyclic. AOPB is cyclic. Now what is the meaning of cyclic? Okay, what is the meaning of cyclic? This quadrilateral is cyclic if these two and these two are making the angle sum equals to what? 180 degree, right? These two opposite angles are 180 degree, these two opposite angles are 180 degree. So, let us prove that. Proof. So, I am not having any type of construction here. I am just going with the what I have given. And now, if I go through with this is a right angle triangle, right? And this is also a right angle triangle. So, I can say that in quadrilateral what? APOB, angle O, not angle O but angle A. Angle A equals to angle B equals to 90 degree. Why? Because OA is perpendicular to AP and OB is perpendicular to BP. You know this is radius and this is the tangent, radius and tangent. So, these are 90 degree. This implies that angle A plus angle B equals to what? 180 degree. The first part is proven. Now this. Now in quadrilateral, APBO again, angle A plus angle P plus angle O plus angle B will be equals to what? 360 degree. That will be for a quadrilateral. Now, if the sum of A and B is what? 180 degree plus angle P plus angle O equals to 360 degree. What this implies? That angle P plus angle O equals to 360 degree minus 180 degree, which is again what? 180 degree. This is second. By second and one, by equation first and second, my students, what are we having? That we can say that quadrilateral APOB is what? Is cyclic. Okay. So, it's proved now. Hence proved. Note it students. Today we have discussed enough, right? So, in the next session we will be coming with more questions and some more interesting theorems. Okay. So, what you have to do, you just have to exercise it, okay, and do some more questions, find some books, and you have plenty of, questions, good questions on the internet. So, find them and take care. Bye. Thank you.